everyone, my name is Sean Copley. I work as an Assistant Director in the ABS's Geospatial Solutions section, and today I'm joined by two of my colleagues, Bryony Anker and Jade Kite, who will be co-presenting today's presentation. So today we'll be using this session to talk a bit about some recent projects that we've undertaken within the ABS that has used geospatial technology to create new insights and also some other innovative products. However, before I jump into the core of the presentation itself, I did want to give a brief overview about some of the broad things that we're responsible for within the ABS's Geospatial Solutions team. So we're quite a large area and we have a range of responsibilities across the Bureau. One of the key pieces of infrastructure that we develop and maintain is the ABS's Statistical Geography, which is the Australian Statistical Geography Standard. And one of the key focuses for us at the moment is updating the ASGS based on population growth across the last 5 years. And we'll start releasing the third edition of the ASGS around mid-2021. And of course, next year is also our next population census, which will be conducted in August 2021. So the new edition, the third edition of the ASGS, will be used to output that census data, as well as other statistical data that we produce within the ABS. In addition to our statistical geography, we also store and maintain and undertake analysis of geospatial data, and we also maintain ABS's geocoding infrastructure to ensure that our statistical data can be accurately linked to a location. And finally, we also do a range of work to output geospatial content on the ABS website. This includes producing digital boundaries of the ASGS, the Australian Statistical Geography Standard, so they're things like shapefiles. We release data in geospatial formats such as geopackages. We create geographical correspondences, so users can convert data between different statistical geographies. And we also produce a range of maps and web services as well. So today's presentation will be split into two halves. Firstly, Bryony and I will talk about some interactive maps that we've been building within the ABS using the Esri infrastructure. And this will include highlighting some of the maps that we built as part of ABS's response to COVID-19. Following that, Jade will then discuss some new products that we've developed in the first half of 2020 that's looked at experimental methods to produce agricultural statistics using new administrative data sources. And that work had a strong reliance on geospatial data. So we'll start with our presentation on interactive maps. I'll give a brief overview, and then Bryony and I will provide some examples of the interactive maps that we've built across the last couple of years. So we've developed a number of interactive maps for both internal purposes and also for publication through the ABS website, so they're available to the public. And these maps have covered a broad range of topics including population, labour, health, and many others. And so really the benefits of these maps are their ability to tell a story about ABS data, or also to give users the opportunity to explore and analyse ABS data in a more interactive way. So as I said, I'll go through some examples, but you can find a more comprehensive list of all the maps that the ABS has published on our ABS Statistical Geography homepage. So if you go to the ABS website and type in Statistical Geography or Geography, you should be able to find that link. So within the ABS, the main piece of infrastructure that we're using for our interactive maps is Esri. So in regards to the Esri infrastructure, this has provided us both an internal and external geographical information system, or GIS. And so first on the left, you can see our internal system, which is the ArcGIS Enterprise portal, or simply the portal, which is hosted internally within the organisation, and it's locked down to ABS staff. So we're currently using the portal to support a range of internal activities, including planning for the 2021 census. We're also using it to support the redesign of our statistical geography for 2021. And some subject matter areas within the ABS are starting to use it in terms of actually validating their data geographically, which is a fairly exciting opportunity. And then on the right-hand side, you can see the external system that we're using, which is ArcGIS Online. And so that obviously hosts the data within the Esri cloud, and it's what we use to put maps into the public domain. So we've been using ArcGIS Online to release maps as part of ABS standard releases. And as I touched on, we've also been doing some work to release new and existing ABS datasets as part of our COVID-19 response. An example of that is our single touch payroll dataset, which Bryony will highlight a little later in the presentation. So my final slide, I just wanted to provide an example of how we've been using the internal portal within the ABS. So obviously the Census has a strong geospatial component, and it's a significant logistical exercise for the organisation as well. And so we want to count everyone in Australia, and so knowing about their location is really critical. So in Geospatial Solutions, we've been using the internal portal to develop a range of maps and tools to assist with census planning for 2021. And this has included designing what we call mail-out enumeration areas, which delineate the area that we mail out census forms to. And so we've been using the portal to help design, showcase and gain feedback on those geographical boundaries from key clients within our organisation, which is our Census branch. And as I touched on, that's a private system, the portal, so it's locked down to ABS staff only, it's secure, and we can even lock it down to specific groups within the ABS or specific individuals as well. So now I'll pass on to Bryony, who's going to talk a bit about some of the maps that we've released to the public over the last couple of years.
Thanks, Sean. So at the ABS, we really started developing online interactive maps last year, and many of our earlier maps were supporting other subject matter areas to present their statistics visually, which makes it easier for the audience to understand the data and see the geographic trends and outliers. For example, this first map here shows the regional population growth by Statistical Area Level 2 and local government area. This is a yearly publication for the ABS and shows the change in population across the country. This map also highlights the top 10 growth areas for each geography, and you can zoom in and click anywhere on the map to get more detailed information about a region. In addition to population growth, we also create a population grid, which models the estimated resident population by square kilometre, which uses a raster. Next slide, please. This has been created as a static map in the past, but this new version allows users to zoom in or search for regions of interest, making it more accessible and helpful to the user. Next slide, please. As we further progressed our interactive mapping adventures, other opportunities arose. Our building and construction team published data on building approvals each month, and we've got a map that shows the current and previous month's approvals by SA2 and LGA, broken down by property type, which is houses, other residential dwellings, and the total number of dwellings. But each year, the building and construction team also publish a summary of key highlights, giving us the opportunity to develop an Esri Storymap, where the spatial data goes hand in hand with the narrative of the publication. Next slide. We incorporated dashboards to display interactive graphs. We've got page index buttons for fast navigation. Next slide. And as there were the three key layers, the houses, other residential dwellings, and the total number of dwellings, we also incorporated simple click buttons to switch between these layers. Next slide. Each state had a page in the narrative with its key figures, and the accompanying map would follow the user's navigation throughout the story. And of course, as with all our maps, you could zoom into the areas of interest and click for a little pop-up with further detail. But of course, as 2020 came along, just like many organisations out there, we had to refocus our work slightly. Next slide. To support the government's response to COVID-19 and assist with planning, the ABS has released several new interactive maps this year. These maps are designed to help both governments and the community to understand and respond to the risks and potential impacts from COVID-19. The maps cover a range of demographic, economic and social characteristics, highlighting areas where a greater number of people who might be at risk from the disease reside. So for example, this first map shows the distribution of persons with various health conditions, such as heart disease, diabetes and asthma, broken down into age groups, those over 70 years, those over 60 years, and the total population. The second map shows the distributions of persons who are employed in particular high-risk industries, including health, hospitality, retail, education. And the pop-up here also shows a breakdown of workers by their different age groups. So other examples of maps within this series have looked at the general population by age, with a focus on older persons, people with disabilities, and unpaid carers. Each one of these maps has been produced using data at the Statistical Area Level 2, or SA2 scale. And SA2s are considered medium-sized community-level regions, and there are about 2,300 of them covering the entirety of Australia. Next slide. To measure the impacts of COVID-19, we have also created an interactive map showing the change in the number of jobs across Australia using single-touch payroll data provided by the ATO. The single-touch payroll system collects salary, wage, tax, and superannuation information for every payroll cycle. The ABS has released single-touch payroll data, including business and job level tax and superannuation information. And this map is part of the weekly payroll jobs and wages publication, and shows the change in the number of weekly payroll jobs since the week that Australia recorded its 100th case of COVID-19. That was the 14th of March, and it also coincided pretty closely with when restrictions first came into place in Australia. If a business, for example, if their pay cycle is something other than weekly, the data has been modelled on established payment patterns. And this map, as you can see, has larger geographical regions, and that's because it's using Statistical Area Level 4 data. In addition to this interactive map, we were also interested in presenting a visualisation of how the number of jobs are actually changing over time at that regional level. Next slide. So we created an interactive time slider map as well, examining the percentage change in payroll jobs each week since that 14th of March. This really highlights the regional impacts of job losses from COVID-19. Now, you might notice this map only goes through to the end of May, but if you're interested in seeing the impacts of COVID-19 and of the restrictions with some more up-to-date data, you can find that on our Geography homepage that Sean mentioned earlier. Next slide. The time slider map is interactive in just the same way as all our other standard maps, so you can pause or manually progress the animation. Next slide. And you can also, of course, zoom in to an area of interest and click on a region for a more detailed information. And we've also included a basic graph just to show the percentage change over time for that particular region. I'll finish off there now and hand over to Jade Kite, who will talk about a recent geostatistical analysis project on the production of sugarcane. Thanks.
Thanks, Bryony. So I will now talk to you through the sugarcane experimental estimates. So this project was the result of asking the question, can we use alternative geospatial data sources together with geospatial technology to provide agricultural estimates? If we can do this, it would reduce the reliance on agricultural census and survey data whilst reducing respondent burden on farmers. Next slide. Sugarcane was chosen for this project because there are already good alternative data sources available in this industry. In addition to that, we needed to be engaging with the industry. So we need to build a relationship and trust, and also listening to their needs and advice. But there was engagement with a number of different sugarcane bodies and groups in order to get this project completed. Next slide. We were able to obtain 3 main data sources for this project. The first was from the Australian Sugar Milling Council. This dataset provides production totals for the 5 sugarcane regions, which have come directly from the sugar mills. The second dataset was the Levy Payers Register. This provided unit-level production data with addresses of each business. And the third was government satellite mapping, which shows the footprint of the sugarcane. Next slide. The first data set, which was from the Australian Sugar Milling Council, is the national production data, which is also publicly available for the 5 regions, which is shown here with the hatching. These are 4 regions in Queensland and 1 in New South Wales. These regions are shown with the SA2 boundaries, which is what we want to publish the data on. Publishing the SA2s at the SA2 level provides a lot of extra spatial detail than we were able to get through survey data. Just click. The circles show the amount of sugarcane in millions of tonnes produced within each region. This data comes directly from the mills through which all sugarcane is processed, so it's very good data and well trusted. This data is also used as a benchmark at the end of the process, which was also happened with our survey data. Next slide. The second data set we have is a satellite or Earth observation derived mapping data, which shows areas where sugarcane was grown in 2019. You can see this data shown in green around the Townsville area, and it's produced by the Queensland State Government. We can use this together with the production data to help allocate the production information to more detailed SA2 regions. Next slide. The third and most important data set is the levy payers register. All farmers will pay levies on the crops that they produce, which goes into research and development. This data is provided to us under legislation by the Department of Ag, Water and Environment. Key variables of this data are business location address and the amount of sugarcane they produce. The totals match the Australian Sugar Milling Council data almost perfectly, but some of the address information is not correct, which means we can't just sum the unit records to the SA2 that they fall within. Some of the address or location issues are business reporting an address, which is located in an urban area, or the business is actually multi-locational, but we only have one address. For the records that we were confident in the location, we simply aggregate to the SA2. For the records with location issues, we applied some data cleaning processes to spread the data across multiple SA2s. Next slide. So we output the experimental estimates at the SA2 level, which is available from the ABS website. So you can gain, this is a snapshot of our website. You can gain the download from the right-hand corner with data download or on the left-hand navigation bar. Next slide. As a part of this project, we also created an interactive map at the SA2 level. The interactive map allowed users to quickly identify key areas, such as Burdekin here, which is the sugarcane capital of Australia. The map also highlights greater regional detail. So through this release, we now have estimates that have better regional detail. We release the data faster than what we do with survey-based estimates, and no survey questions were asked to the farmers. So thinking back to that question we asked at the start, yes, we can use alternative geospatial data sources together with geospatial technology to produce estimates for sugarcane. Next slide. If you have any questions about our presentation, you can email us at geography@abs.gov.au. Thank you.